is a special case of the wrapping around different axes that sometimes comes up. And the only decision you end up actually having to make is who is the upper curve and who is the lower curve. And it just happens when instead of the axis you're rotating be below the graph, it might be above the graph. But in the end, that axis is always the lower. And let me show you what I mean with one case. I'm only going to show you one scenario on here. I'm going to find the volume of a rotated solid bounded by the curve y equals negative x squared minus 5, and the line y equals 4. Okay, so just like on all the other problems, it's going to be the same thing. Pi, the integral of r squared, and whichever direction I'm chopping along, I already know it's going to be dx. I'm already looking at that problem right now. But look what these two graphs will look like when I put them on there. And this is going to be between 0 and 1. Sorry about that. When I graph this, this is the curve. Y equals negative x squared minus 5 between 0 and 1. And here is the line. I'm going to wrap it around y equals 4. So when I wrap it, it's going to go like this right here. The same shape we looked at all these other ones on to begin with. I'm going to talk about that kind of like that. So before we begin, this is going to have more volume than if I wrapped it around that axis right there. The reason we don't need any other extra numbers, we don't have to worry about if we get a radius that's positive or negative, because it doesn't matter in the end. Even if we mess it up, because we're always squaring the radius in the problem, whatever number we have is always going to become a positive number. And the answer is it's always upper minus lower. You notice I've drawn the picture right here. I'm going to draw my axis right here. Upper is the one on the outside, and lower is the one on the inside. So the upper curve is going to be y equals negative x minus 5, upper. And the lower curve, bound, is going to be 4. Why is that the case? Because upper refers to the outside. If I rotate this up to the top, it's on the outside there. Sometimes you say outer and inner, but if we stick with upper minus lower, we're going to be okay. Upper is the outside curve that you have right there. So the upper is going to be, and I'm going to show you why this will end up working out, it's going to be y minus 4. Now I know what you're thinking, well that doesn't make any sense. I'm subtracting off of 4 from there. Let me just show you why it's always going to work out right. And it's going to be okay. It's going to give me a bigger number than I would have had before. The radius is going to be upper minus lower, which is y minus 4 dx. Integral with the pi out in front, 0 to 1, of y minus 4 dx. Why will that give me a bigger number than if I wrapped around the axis? Well, what's going to happen is here is the y value. And the y value is a negative number. So just pick a number. It might have been negative 7. So if it was negative 7, and then I subtract 4 off it, I get negative 11, which is a bigger quantity than negative 7. But in the end, because it's r squared, the negative sign ends up going away. So those values don't play on our problem at all, as long as we know the outside curve is our upper curve. And if you don't believe it when you see the picture, draw the whole thing wrapped around. This distance right here is still going to be y. That's your outside curve. So this would be the correct one for this one right here. I've got to change the y to be in terms of x. So it'll be 0, 1. Now I'm going to keep the parentheses. Negative x squared minus 5 minus 4, everything squared dx. And I can put that in the calculator, and I would get an answer back as we're going there. But you can even see, even at that point right now, when you combine the negative 5 and the negative 4, your quantity is getting bigger, but your number is not. It's going to give you a negative number, because this radius from here to here is going to be a negative quantity. Negative. But when we square it, it's going to become a positive quantity. So in this special case, don't ever worry about which one's on top, which one's on bottom. The axis is always the lower, always going to be the lower. And we just use numbers we have. If you don't believe it, draw the whole thing, and then you'll see that your curve, your outside curve y, is still going to be on the outside.